In the realm of sustainable construction, understanding the environmental ramifications of our choices is paramount. Enter Life Cycle Assessment, or LCA, a powerful methodology that allows us to quantify the environmental burdens associated with a product, process, or service throughout its entire life cycle. This spans from the extraction of raw materials to manufacturing, use, and ultimately disposal or recycling. Imagine being able to compare the environmental footprint of different building materials or construction techniques. LCA empowers architects, engineers, and contractors to make informed decisions that minimize environmental impact and steer the industry towards a more sustainable future. By embracing LCA, we can move beyond a narrow focus on operational energy efficiency and embrace a holistic perspective that considers the true cradle-to-grave impact of our buildings. The importance of LCA in building projects cannot be overstated. As the construction industry grapples with its significant environmental footprint, LCA offers a pathway to mitigate negative impacts and promote eco-conscious practices. By integrating LCA into the design, construction, and operation phases, we can create buildings that are not only aesthetically pleasing and functional, but also environmentally responsible. The LCA process is typically structured into 4 distinct, yet interconnected phases: goal and scope definition, inventory analysis, impact assessment, and interpretation. Each phase plays a crucial role in building a comprehensive understanding of the environmental performance of a building project. Goal and scope definition sets the stage for the entire LCA by clearly defining the objectives, scope, and system boundaries of the study. This phase ensures that the LCA is focused and tailored to address specific environmental concerns. Inventory analysis involves compiling a detailed inventory of all the inputs such as energy, materials, and water, and outputs like emissions and waste associated with each life cycle stage of the building. Impact. Assessment translates the inventory data into environmental impacts. This is achieved by using specialized databases and assessment methods to quantify the potential effects of various emissions and resource consumptions on human health, ecosystems, and resource availability. Finally, interpretation involves critically analyzing the results of the impact assessment to draw meaningful conclusions and identify potential areas for environmental improvement. This iterative process allows for a comprehensive evaluation of the environmental performance of a building project, enabling informed decision-making and the identification of opportunities for environmental optimization. Accurate and reliable data lie at the heart of a robust LCA. Gathering the necessary information can seem daunting, but a systematic approach can streamline the process. The type of data required for an LCA will vary depending on the specific goals and scope of the study. However, common data points include material quantities and types, transportation distances, energy consumption during construction and operation, water usage, and waste generation. Sources for this data can range from architectural drawings and specifications to manufacturer data sheets and industry databases. Engaging with suppliers and contractors early on can prove invaluable in obtaining accurate material and energy usage data. For instance, understanding that the embodied carbon of different concrete mixes can guide material selection towards a lower carbon solution. Accurate data on construction waste generation can inform strategies for waste reduction and recycling. Remember, the quality of your LCA is only as good as the data that fuels it. Thorough data collection ensures that your LCA provides a realistic and reliable assessment of your building's environmental performance. Section 4: Software Tools, navigating the digital landscape of LCA. Thankfully, you don't have to be a spreadsheet wizard to conduct an LCA. A range of software tools has emerged to simplify and streamline the process. These tools provide user-friendly interfaces for data input, perform calculations, and generate reports that visualize the environmental impacts of your building project. Some popular LCA software options for building projects include Athena Impact Estimator for buildings, Tally, and One-Click LCA. These tools often come equipped with pre-populated databases of building materials and construction processes, reducing the manual data entry burden. They also offer features such as scenario analysis, allowing you to compare the environmental performance of different design choices. When selecting an LCA software tool, it's essential to consider factors such as ease of use, data availability, and reporting capabilities. Some tools are better suited for specific building types or life cycle stages, so choosing one that aligns with your project needs is crucial. The software should seamlessly integrate into your existing workflows and provide actionable insights to guide your decision-making. Section 5. Goal and scope. Definition setting the stage for success. As with any journey, a well-defined destination is crucial. In LCA, this begins with the goal and scope definition phase. This phase outlines the purpose of the LCA, the intended audience for the findings, and the precise boundaries of the study. Clearly articulate the environmental aspects you aim to investigate. Are you interested in greenhouse gas emissions, water depletion, or perhaps the impact on human health? Defining the scope involves specifying the life cycle stages to be included in the assessment. For instance, will your LCA cover the building's construction, use, and demolition phases, or will it focus solely on the operational energy use? System boundaries determine which processes and materials are included within the LCA. For example, will you consider the transportation of materials to the construction site or focus only on the on-site impacts? A well-defined goal and scope acts as the compass for your LCA, ensuring that your efforts remain focused and relevant to your project's sustainability objectives.